Usually it's non-polar. We'll see how that works. Usually it's non-polar. So you're fine, right? That's pretty good.
Are there any polar organics?
There are slightly polar. Yes. Not as polar as a non-organic. Inorganic it's called. But anyways, okay, so back to her question. So hydrocarbons are carbon and hydrogen. They are organic, obviously. They are covalent and they're non-polar. So mineral oil is made up of hydrocarbons. Yeah, have you guys heard of mineral oil before? Yeah, it's a solvent. You can buy it in hardware stores, maybe even the grocery store. I don't know. But mineral oil dissolves a lot of things or mixes well with a lot of things that are also non-polar. For example, ester oil is also non-polar. So the reason that you wrote that down is because they're both organic, they're both hydrocarbons, they both have non-polar properties, so they both dissolve. Like dissolves like. Does that make some sense? They have similar forces of attraction, which brings me to the next question. What forces of attraction do organics have, in general? Weak, which means they have low or high melting points. Low, like wax, melts easy. What type of forces? We wrote this yesterday. Van der Waals or dispersion, right. Okay. True or false? Organic molecules conduct electricity. False. There's no ions. Good. I think I hit them all. I think that was all the things I wanted to review with you right now. So we have tables P and Q should be out. If they're not, take them out. Tables P and Q. We left off talking about alkanes, correct? Okay. So alkanes are called saturated. Remember that. They're called saturated hydrocarbons. They have as many hydrogens as they possibly can. Guess what alkenes and alkynes are called? They're not called saturated. Unsaturated. That's what they're called. Right.
How come there's no alcohols?
I don't know. So we'll talk about those down the road, though. All right. So now back to the alkane here. Did we get any examples? I think we got chopped off or cut off.
Methane and propane.
All right. So we did methane and propane. All right. So here's what I want you to do. Let's go with. Let's write butane. Let's write butane. You write it all the way on the left side of your notes, as far left as you can go. Butane. And hopefully you have a little space above it. Hopefully. So next to butane, I want you to write molecular formula. Molecular formula.
Wait, above?
Yeah, kind of above it. Yep. You're going to be drawing a formula underneath it of butane. Next to that, you're going to do structural formula. And then over here, condensed structural formula. So there are different ways to write or draw the structure and or formula of these hydrocarbons, and you're going to learn today how to do that. Tomorrow you'll start having worksheets for organics. We're just not ready yet. So butane. First of all, Ben, if I write the name butane on the board, how do you know it's a alkane?
It ends with an A.
It ends with ane. Good. It ends with ane. A-N-E. Now, Destiny. How many carbons does butane have? L-M-N-O. P. Table P. How many carbons does butane have? Four. Very good. See, I wanted you to have that moment where you're like, oh, I get it now. Good job. So butane. But is how we say that. B-U-T, not but it's but. Has 4 carbons. 4 carbons. So we write C4. Now, go to table Q. Plug that 4 into the formula, the general formula for N, and tell me, don't say it out loud, but tell me how many H's does butane have? And Tara, go ahead. 10, very good. C4H10. Because the general formula for alkanes is CnH2n plus 2. So, why is that useful to you? If I give you the name, I expect you to be able to give me the formula. if I give you the formula, I expect you to tell me that's an alkane. How do you know? Because this will only fit or only match the alkane general formula. What does that mean? If I put a 4 in for this one, that's the alkene. If I put a 4 here, what's that become? 8. So C4H8 can't be an alkane. It's an alkene. It has a different formula. So that's what we're trying to practice here, is to make sure we understand how to use that general formula and how it applies to the name and the formula. Okay? So butane, 4 carbons, how do I know? Table P. Ane means alkane, so we're using that general formula. Now, structural formula is when you're going to be drawing on the paper things that look like this. Okay? This is the structure. This shows the structure of an alkane. Would anyone care to tell me the name of this alkane? You got to raise your hands up. What would the name of this alkane be? The black ones are carbon, the yellow ones are hydrogen. Eden? Propane. Prop because 1, 2, 3 carbons, right? Single bonds, that's alkane. So prop means 3, we know it's an alkane, so propane. You could count the carbons up too, but it'd be C3H8. So that's propane. So this structure you're going to draw, except we have 4. Instead of 3, we have 4. Here's how we do it. We always draw the carbons in a straight chain. 1, 2, 3, 4. Always draw your carbons in a straight chain. That's called a straight chain alkane. That's what it's called. Straight chain alkane. But we'll write that later. So you got 4 carbons. 1, 2, 3, 4. Now, how many valence electrons, Catherine? How many valence electrons does carbon have? 4. So how many bonds can it make? 4. Carbon has 4 single dots. 1, 2, 3, 4. It can make 1, 2, 3, 4 bonds. Can it make 5? No. Can it make 3? No. It has to make 4. Burn that into your memory banks. Carbon has to make 4. It must make 4 bonds. So, this carbon has 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So those dashes represent the hydrogens. So there's all your hydrogens. So label your hydrogens. This is the structural formula for butane. 4 carbons, 10 hydrogens. You can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, go ahead. What? Huh? What? It is tedious. So eventually, I actually stopped labeling H's, but
just
you.
put 1 H.
Well, yeah, you have to label all of them. Why?
I'll remember that.
Because that's my rule.
That's just dumb.
Yep. Condensed structural. Listen carefully. See if it makes sense. The condensed is just like structural, just like this, except you don't show the carbon-hydrogen bonds. You condense that. So this, I'm going to actually, you can put it next to it, but I'm going to put mine underneath it so I can show you what I'm talking about. So the CH, the C with the 3 H's becomes CH3. So I collapse my H's. I don't show the bonds. This bond stays there. This CH2 becomes, well, CH2. But we combine the C's and the H's there. We don't see the bonds. That bond stays there. This becomes another CH2. That becomes a CH3. So that's called condensed. The Regents really focuses on this one, structural. They want to know that you know how many bonds to draw. That's why they ask that. They also ask this one too. This one not so much. Why am I showing you? Because if you become, well not become, but if you go to college and you take any kind of chemistry and they have you draw these, they have you do this a lot. This is kind of how real chemists do it, or real people who really draw these things or write these things out for research, for articles, for whatever they're doing, science in general. They don't do this. It takes way too long, so they do condensed. So I'm just showing you kind of the way you're supposed to do it. But the Regents is going to go with here or here. Questions about anything I just put up on the board? Okay, good. So structural, molecular, and condensed. That's just for butane. Let's try another one. I want you guys to give me the molecular formula and the structural for, oh, I don't know. Let's go with pentane. I want the molecular formula and the structural formula for pentane. Then I gotta teach you one more property, or one more, property. So I'm going to come around and check your work. Again. Here we go again with the floating numbers.
What are you doing?
No floating numbers. Numbers don't float. Look where I put, like that. Sync. Numbers sync.
I don't know why I did that.
It's okay. I'm just worried that I'm going to have to get in a fist fight with another teacher.
Why?
In June. Because if you have the right formula, but you put the numbers a little bit too high, they might.
No.
Right, and I'm going to be like, alright.
Hey, what do you mean another fist fight?
Did I say another?
Yeah.
Hey,
Oh. I mean after I fight a meat. And I have to.
okay.
I'm gonna fight this for now.
Oh, you're not gonna fight me, you know.
You know I'm not going to fight you.
Because of
No.
You'll like hit me with a guitar or something. Alright,
Oh, come on.
now, pentane, what's the formula? Who knows? Molecular formula.
Nobody gets that.
C5H12. Good job. Now, the structural is pretty easy. Again, all we do is 1, 2, 3, 4, 5. Straight chain. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's your structural. And of course, you need to label your H's. But again, I'm going to be a little lazy, and that's okay. You can't be, though. That's just how it works right now. You're getting graded, not me. So there's the structural drawing. Now, I got a little sloppy with the lines. Just make sure 4 lines per carbon. That's it, 4 lines. Which brings me to my next question. Why do these 2 carbons have 3 H's, but everybody else has 2? Dan?
Because 2 of the bonds have already been taken.
Right.
Because they're
Like
on the
these
side.
2.
Yeah.
So this carbon in the middle can only have 2 hydrogens because it's already bonding once here and once here. So that's 2. It only has 2 left. 1, 2. So that's 4. The ones on the end only made 1 bond. So they can have 3. So just keep that in mind. It's only at the ends or the beginning, however you want to look at it, that they have 3. Okay. Questions so far? Alright. Now, I don't know why I erased that. Underneath that, I wanted you to write this. It's called a straight chain alkane. Straight chain alkane.
Sounds like a
Okay.
rap song.
I guess a little bit. So that arrow's going to that phantom molecule I just had there. So you should point the arrow up to your pentanes, okay? So connect that up to your pentane.
Which part of it?
Just the whole thing. The whole thing is called a straight chain. Let me put it up here again. So that thing is called a straight chain alkane. Why? Because the carbons are in a chain and they're straight. Now here, in real life, they actually have a little bend to it. This is pretty realistic. On paper, though, we don't draw it like that. We draw it in a straight line.
I feel like it'd be difficult to draw like that.
Yeah, you would have to, yeah. So, that's called a straight chain alkane. I want to show you something else. On the left side, put methane. CH4. Boiling point. Negative 161.6 degrees Celsius, I think. Hold that thought. Yes, negative 161.6 degrees Celsius. Propane. C3H8. Boiling point to be determined. Pentane. C5H12. Boiling point. 36.1 degrees Celsius. I'll give you the propane in.
Wait, what do you mean to the different?
I have to look it up,
Oh.
but I have it. Alright, forget it. I'll Google it real quick. Boiling point of propane.
How many words meant?
Negative 42 degrees Celsius. What'd you say? Dan?
How many words meant?
I don't know. A
Wait,
decent
then how
amount
do
when
you
I
use
get
like
going.
propane gas?
Now, good question.
No.
What am I trying to show you? Why do we just write those three on the board?
Or the more numbers, the stronger they are.
The more numbers, the stronger they are. I need
The
something
more
better than that.
carbons.
The more carbons,
Right.
Stronger the bond.
The more bonds.
the bonding's all the same, right? They're all covalent. So there's more forces, I'll give you that, but not bond. There are more bonds too, but it's not the strength of the bond, strength of the force. So you guys are pretty much right on target there. If you have more carbons, what happens to the boiling point?
Goes up.
It goes up because the forces go up. So as the number of carbons increases, the boiling point increases. And this is due to more forces of attraction. Sorry, I'm running out of room here. More forces of attraction. That's really messy. So if you have more carbons, there's more electrons, which means more dispersion forces, because that's what dictates dispersion forces, the number of electrons. So the last thing I want you to do, you can put it underneath, but I have room up top. I'm going to draw a little graph. Boiling point here, number of carbons here, and it looks like that. Direct relationship. As your boiling point goes up, your carbon number will go up as well. So as the boiling point goes up, or sorry, I should say it the other way around. As the number of carbons go up, the boiling point goes up as well. So that was kind of the last thing I wanted to cover here today, because the bell is going to ring. But hold on, don't pack up yet. So it's important to understand the alkanes, because they're the most common on the regions, as far as what are they? Single bonds, hydrocarbons, how to use the tables to give you the formula and or name. Okay, you should be pretty good at that at this point. And then the concept with this. As the number of carbons increases, boiling point increases. That actually has real life implications, because when you get crude oil, there's like millions of hydrocarbons in it. And what happens is they separate the hydrocarbon compounds in crude oil using this concept. It's like a big chamber with all these different valves on them, and they have different temperature zones. This could be the hottest, next hottest, next hot. And what happens is the hydrocarbons evaporate, and then they condense out the side of this chamber based on temperature. So we'll talk more about that tomorrow.
Okay.
Don't forget your homework, that one worksheet on equilibrium.
Friday, so it's chapter 3.
Yes, chapter 3 and journals due Friday. Yes, sir.
The homework for yesterday.
Yes. How are you feeling?
Yesterday.
Not too bad, huh? At least the day's over now.